So what are we doing today? So we're solving quadratic equations, okay? Any clue how we're going to solve quadratic equations today? Okay, probably by graphs and factoring because that's what it says on the worksheet, right? But what I need you to know about the rest of this week is we're going to work on this worksheet for 2 days. Okay, solving quadratic equations by graphs and factoring. So today we're actually going to just solve quadratic equations by graphs. Tomorrow we're really going to focus on solving it by factoring. Okay, then Thursday and Friday we're going to solve equations by the quadratic formula. There's lots of different ways you can solve quadratic equations. These are the 3 that we're going to focus on. Okay, graphs, factoring, and formula. All right. So what is a quadratic equation again? It makes a parabola in its graph. Good. And what's the other thing we talked about yesterday? Squared. That's the highest exponent, right? It has a squared. Okay? So let's consider this equation right here. Show numerically that x equals 5 is a solution. How do we show numerically that x equals 5 is a solution? Plug it in, right? So x equals 5, so I have 5 squared minus 8 times 5 plus 15 equals 0. Anybody know what what 5 times 5 is? Oh, excellent, 25. Anybody know what 8 times 5 is? 40 plus 15. Do you guys hear that banging too, or is it just in my head? Okay, you hear it? All right, good. That makes me feel better. What's 25 minus 40 plus 15? It's 0, right? Does 0 equal 0? Math. Okay? Now, there is another solution to this equation. So we're going to use this table right over here to find it. Okay? Do you think it's 1? Well, how could we figure it out? 1 squared minus 8 times 1 plus 15. 1 squared is 1 minus 8, because 8 times 1 is 8. What's 1 minus 8? Negative 7 plus 15 is 8. Is that a solution? What makes something a solution? If it equals 0, right? Does this equal 0? No, it equals 8. So is it a solution? No. What about 2? Could 2 be the answer? 2 squared minus 8 times 2 plus 15. 2 squared is 4. 8 times 2 is 4 minus 16 plus 15? 3. Is that a solution? No. Wait, what makes it a solution again? When what equals 0? When y is 0, right? Okay. What about 3? 3 squared minus 8 times 3 plus 15. What's 3 squared? 9 minus 24 plus 15. Ooh. Is that a solution? Yes. Is 4 a solution? Four squared times 8 times 4, or minus 8 times 4 plus 15. 4 squared minus 32 plus 15. Negative 1. Is that a solution? No. Now we already did 5 squared minus 8 times 5 plus 15, right? We already know that's 0, and we already know that's a solution. Okay? What about 6? 6 squared minus 8 times 6 plus 15. 6 squared minus 48 plus 15, 3. Okay? So how many solutions do I have on this table? 2. 2 solutions. Does everybody see that? Okay? Using the table above, plot these points, the x and the y, to sketch the graph of this function. So 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 3, 0, 4, negative 1, 5, 0, and 6, 3. Which 2 points represent the solutions to the original equation back up here? What points are they? Three, 0, and 5, 0. Where are those points located? X-axis. They are on the x-axis. Is that important? So important. Okay? So very important. Now, in this method, we use the trial and error method. You want to do some more of those? Guess and check? Yeah, me neither. Don't like them. Okay? Remember I told you we would do it 3 ways. Here's the 3 ways. Graphs and tables, factoring, and quadratic formula. These are the 3 ways we're going to solve quadratic equations. Okay? Regardless of which way we solve it, there is some vocabulary that I need you to know. Okay? Look at this equation right here. How many variables are in this equation? I have an x. Do I have any other variables? No, so I only have one variable, just the x variable. When we're dealing with general equations like this, with x's but no y's, the answers are called solutions or roots. Why are they called roots? Don't know. No idea. Okay? However, I know that vocabulary shows up in different places. I need you to know it. Okay? When we're dealing with functions, however, when there is a y and an x, then the answers are called zeros or x-intercepts. So am I really telling you that there's 4 different words that mean relatively the same thing? Yes. And if that seems a little ridiculous to you, please know that it seems that way to me as well. Can we just have one name that we call stuff? Apparently not. Okay? That's not my choice. I wasn't around when they were designing all these words. Okay? So, let's do part 1. Let's look at graphs and tables. Okay? The example is there for you if you want to refer back to it as we go through number 1. Here is an equation that's already factored. Okay? I would like the expanded equation. How do we find the expanded equation? How about x times x, which is x squared, and then x times 1, which is 1x, and then negative 4 times x, which is negative 4x, and negative 4 times positive 1, which is negative 4. What happens when I combine my 2 middle terms? So x squared minus 3x minus 4. You okay with that? Okay. Do I always just combine the 2 middle terms because they're in the middle? Or is it because they're like terms? They both have an x. I just want to make sure that that was clear. Okay. Now, what does this look like on the graph? since we all picked up our calculators, we're good to go. So x minus 4 and x plus 1. Does yours look the same as mine? Did anybody put in the expanded equation into their calculator as opposed to mine? Brooke, let me see yours real quick. Let me see your calculator. I gotta show you something. Here's mine. You guys saw what I put in, right? I put the factored equations in. Here's Brooke's. She put the expanded equation in. It's the same thing. Did we expect it to be the same thing? Should it be the same thing? Absolutely. Okay? Thank you very much for sharing that. Okay? So now what I need is I need my graph. Now, we have been really focusing on graphing really beautiful parabolas by getting exact points for 4 days. Are we good with that? Can we just do some general sketches without getting so exact for a little bit? Is that going to throw anybody off? Okay, so what's important on this graph right here? Probably that point, and probably that point, for sure, maybe the vertex. Okay, can you tell that's crossing the x-axis at -1? Can you tell it's crossing the x-axis at 4? So it goes something like that-ish. So please tell me, where are my zeros? You can refer back up to the example if you want to, but where are my zeros? X is at -1 and x is at 4. Please remember back to yesterday when we were talking about how factors and solutions were related. Do you remember that? How are they related? And if you can't remember, look at it now. How are the factors and the solutions related? They're opposites, right? Now, that definition will work for a little while until we get to a problem later. So can we go ahead and correct our language right there? I know I started it. It's fine. I needed to get you guys on the right track, but now I can fix something for you. Okay? What happens if I put a -1 in right there? What does that parenthesis become? 0, doesn't it? What happens if I plug this 4 into this one? What happens? So really, it's my zeros are what make each of these parentheses equal 0. Does that make sense? Now, on ones like this, is it okay if we think about the fact that they're opposites? Absolutely. Absolutely. Okay? I just want you to be careful, because you'll see what I'm talking about here in a little while. Okay? All right, so here's my factored equation, number 2. Here's my factored equation. What's my expanded equation? Y equals x squared plus 9x plus 18. Oh my gosh, how in the world did I do that without writing down any work? Well, I know it's x times x. That's going to give me x squared, right? And then I know I do x times 6 and 3 times x, and those are going to be my like terms. So in my head, I can actually add 3 and 6. Yes, I can. And you guys can too. And then just go straight to 9. And then I do 3 times 6, which is 18. Am I being silly? Yes. Do I care? No. Okay? If it helps you remember what to do, I'm okay. So, what's it going to look like in my calculator? Wait, can we make a prediction of what we think it might look like in my calculator before I even put it in there? What do you think it's going to look like? Based on this example that you can look at and see, based on this problem we just did, what's this graph going to look like? Number one, we know it's going to be a parabola, right? And that might seem a little bit silly for some of you, but that's a very good starting point for some of you as well. Okay? Yes, we know it's going to be a parabola. Do we know anything else about it? Do we know where it's going to cross the x-axis? Do we think we know anyways? Where do we think it's going to cross the x-axis? And -3 and -6? And why do you think that? Those are the zeros? Okay. Based on these factors over here? All right, let's go see if we are correct. I think this time I'll put in the expanded equation because I put the other one in last time. I just want to make sure you understand that they're the same, or they should be. Oh my gosh, look at that. It crosses a -3, -6. We are so smart. -3, -6. So, oh, I didn't even go through the points. Act like I went through the points. Sorry. So where are my zeros? X is -3, X is -6. Okay so far? Okay. What about number 3? Y equals, yes, that's a good start. X squared. How about minus 10x? Plus 25. Very good. Now, some of you are starting to be able to do those in your head, and that's great. If you still need to do this kind of work up here and have this step and go to here, please do it. Please do it. There's not going to be any points taken off or anything if you're still showing your work like that. That's totally fine. However, if you can go here, go. Okay? So let's make a prediction on this one. What's it going to look like? It's going to be a parabola. What else do we know? It's going to cross at 5. And what? How can something cross at 5 and at 5? Well, let's see. X minus 5 squared. Oh my goodness. The parabola is sitting right on top of the x-axis. And where is it touching the x-axis? At 5. Does that make sense? So where are my zeros? X equals 5? Because my zeros are where the parabola crosses the, yes, x-axis. If it only touches in one place, is it okay for me to have 1 0? Yeah, absolutely. Okay. Or what about number 4? Oh, this is not a pretty one, is it? Okay, so I know y equals x squared. I know I've got a 2x and a negative 2.5x. So that is, x squared minus 0.5x. And then I've got negative 2.5 times 2, which is a negative 5. But then I have to multiply everything by negative 2, right? So I have negative 2x squared plus 1x plus 10. So where is that going to cross the axis? What are my zeros for this problem going to look like? Any guesses? Where's one place that my parabola is going to cross the x-axis? -2? I agree with that. What's another place my parabola is going to cross the x-axis? -2.5 or positive 2.5? Positive 2.5? Because positive 2.5 is what I have to plug into this parentheses to make that 0, right? Okay? So I have one here and one here. Now, does this 2 do anything to my parabola? It stretches it, right? Makes it skinnier and taller, maybe? What does the negative do to it? Oh, reflects it. So it's not going to go this way, is it? It's actually going to go this way, and it's going to be like taller and skinnier, something like that, maybe. So where are my zeros? X equals -2. X equals positive 2.5. Now wait a second. I haven't even looked at my calculator one time on this problem. Yeah, I heard Sarah say in her head, she's like, so? Isn't that an appropriate response? Do we know all the information we need without having to go to our security blanket calculator? That's okay. All right, that's okay. Number 5. How is number 5 different? Yeah, we have to find the factored form, don't we? Okay? So, some of you, I know this is your favorite part. We got to factor this, don't we? Well, it's a trinomial. My leading coefficient's not 1, so I can't do the little shortcut, can I? I got to find AC. AC is -24. And B. What's B? 5. Good. So what two numbers multiply to be -24 and add to be 5? Well, 1 and 24, 2 and 12, 3 and 8. Ooh, 3 and 8, right? If what? If the 3 was negative. Good. So I'm going to rewrite my problem, and I'm going to split my middle term into two different parts. I have y equals 2x squared, and then these are my two parts, right? Minus 3x minus 8x minus 12. Excuse me, plus 8x minus 12. You remember what to do from here? Good. Look at just the first two terms. What do the first two terms have in common? An x. What's left if I divide an x out of each term? (2x minus 3). What's common in just the second two terms? 4. What do I have left if I divide a 4 out of each term? 2x minus 3. What did I factor out of each term? X plus 4. And what did they have in common? 2x minus 3. Very good. Guess what that is? That's my factored form, isn't it? So I have y equals x plus 4 and 2x minus 3. So can you tell me what my zeros are going to be before I even draw the graph? Where are my zeros going to be? X equals what? -4. Ooh. Remember I told you there would be a tricky part coming up? If I put in a -4 here, I get -4 plus 4. Isn't that 0? So that's definitely a 0, right? Guys, what happens if I put in a 3 right here? I get 6 minus 3. Is that 0? Ooh. This is one of those places where we really have to concentrate on what makes that 0. And the easiest way to do that is like this. What makes it equal to 0? Okay? Set each of the factors equal to 0. Remember we talked about earlier that that's really what's happening here? But when it's a simple one, I can just really think of it as the opposite. Please remember, you have to understand what math is going behind it before you can use the shortcut. You have to notice that we can't use the shortcut on this one because we actually have to solve for x. And if you want to get technical, really what you're doing every time is solving for x. So where's my other 0? 1.5. Does that make sense? Why? Any questions about it? Okay. Can I graph it? 1, 2, 3, 4, and 1.5. Does it open up or down? How do you know it opens up? It's not negative, right? That leading coefficient's not negative. So maybe something like that. Any questions? What about number 6? There's a giant X through my box. Is there a giant X through your box? Why is there a giant X here? What's supposed to go here? The factored equation. Go ahead and factor the sum of squares. Dun dun dun. Can you factor the sum of squares? It's prime, isn't it? You can factor the difference of squares, but can you factor the sum of squares? No. Okay? So let's look at this one in the calculator. That's really the last place that we have to look at it, isn't it? Okay? So I'm going to hit tab to get my equation up. X squared plus 4. Probably not. Did I do something wrong? But I thought our solutions were the parabola across the x-axis. Aren't they? Yes? So doesn't this look like a transformation like we've been doing the last couple days? The parent function scooted up 4, right? Up 4. Where are my zeros? Is that allowed? Are we allowed to have no solution? Yeah, as long as you write no real solutions. And you're probably laughing. You're like, oh my gosh, it means if there's no real solutions, maybe there's some imaginary solutions. Guess what? There are imaginary solutions. And we're going to get to that in a couple days. Okay? I don't want to spoil it, though. I don't want to spoil it. Look at number 7. How is each factored equation related to its zeros? How is each factored equation related to its zeros? Now, we talked about that way. That's the shortcut, right? Saying it's the opposite, but what's really happening? The factors are set equal to what? To 0. If I could spell 0 right, that would be helpful. To find these zeros. Wait, the factors are set equal to 0. Wait, why are they called zeros? Because we're setting them equal to 0, right? That gives us a little hint about why they're called zeros. Okay? Look at number 8. Equation number 3 uses the same factor twice. How does this affect the graph of its related function? It just touches the x-axis in one spot. There's a special name for those, and we'll get to it here in just a second. I don't want to spoil it. That's also foreshadowing. Equation 4 uses a negative coefficient in front of its factors. How does this affect the graph of its related function? It reflects it. Now, I don't really like that sentence at all because there's too many pronouns in there. But I want to respect your words. Okay? So can we at least talk about what it and it means? What is the first it referring to? The -2, right? The -2 reflects what? The graph. Or the parabola. Yeah, that's fine. Okay? The fundamental theorem of algebra states that a polynomial equation of degree n has precisely n complex roots. So what does that mean in English? The fundamental theorem of algebra is the name of the theorem. Okay? It says that a polynomial with a degree n with the highest exponent of n has n complex roots. So what's the degree of a quadratic? What's the highest exponent in a quadratic? 2. How many complex roots should it have? 2. So here's the 3 possibilities, right? Here's our 3 possibilities. It could either cross twice, it could cross once, or it could cross not at all. Okay? What's happening here? It says 2 complex roots. This is really 2 real roots. Because I can actually find those 2 points, can't I? Okay? What about this one? 1 what? It is 1 real root. This is where I was telling you it has a special name. Okay? Because there's supposed to be 2. This says there's supposed to be 2, right? There's 1 real double root. This is when it looks like this. Don't I have 2 roots? A 5 and a 5. Well, I can't graph a 5 and a 5 any different. It's right on top of each other. So I do really have 2 roots, but we really say that it's 1 real double root. It just happens twice. Does that make sense? Okay. What about this last one? 2 imaginary roots. Okay. Any questions about that? Okay. Before I get too far, please turn to the very back to the practice problems. Your homework for tonight is going to be 1, 2, 3, and 4. 1, 2, 3, and 4. Guess what we're going to do for homework tomorrow night? Dun, dun, dun. Go back to the sample problems. I'd like to take you through some sample problems real quick while we still have time. Okay? So the first one says, here's an equation, give me a table. Well, you can plug all these numbers in for x if you want to, or we can turn our calculator back on. And I can put in x squared minus 2x minus 3. And then go to my table, Control T, right? Now I happen to have 2 equations in here. We're only looking at the first column, aren't we? So if I arrow up so I could get to -2. Oh, sorry. We're looking at just the second one. That's weird. They have f of 2 here and f of 1 here. Strange. Okay, so 5, 0, -3, -4, -3, 0, and 5. How many solutions am I supposed to have unless it's a double root? 2. Where are they? X equals -1 and x equals 3. And how do I know what to look for? With the 0 in the y column, because that's how I know it's on the x-axis, isn't it? Okay. Do I need to do B, or you got that? Okay, so look at C. I'm going to go back over here, press my enter or my arrow here, and press Control T to make the table go away. Tab. I want that one to go away too. Tab. Why didn't it go away? I don't like that. So I have x squared minus 4x minus 5. Okay, so where is it crossing the x-axis? -1 and 5. 1, 2, 3, 4. And it looks like that-ish, right? Guys, it's asking for my x-intercepts. I can like officially write this, but an x-intercept is really a point, isn't it? So shouldn't we really write it like this? Right? That seems weird to me, that it's saying that we could do it both ways, or all one way, even if it's asking for a 0 or an x-intercept. I just kind of need to be picky about an x-intercept, because an x-intercept is a point. And so I want to write it as a point. I don't want to get confused by that vocabulary, okay? Let's look at f. What are the zeros of this function? X is -3 and x is 2. What are the factors then? X plus 3 and x minus 2. How do I find the function? Just like I did right here. If I had the factors, I need to find the function. Okay? So I can do y equals x squared. I have a minus 2x and a plus 3x, which would give me 1x, and then a minus 6. Done. Any questions? Okay, you do have 1 through 4 on the back. Those are the ones I'll check for you tomorrow. Any more questions?